This short video is a documentary of our tour of the Brayton Point Power Station, located in Somerset, Massachusetts, owned and operated by Dominion Energy. We begin with the drive-down access road leading to the plant, where the sheer magnitude of the cooling towers would amaze any passerby. We parked our cars and made our way to the security checkpoint, where we met our guides, two lead engineers for the cooling tower project. We were issued personal protective equipment consisting of hard hats, safety glasses, and reflective vests. Safety is the #1 priority at Dominion. It all starts here, where the primary fuel source, coal, is received by barge every 3 days, at a whopping 45,000 tons per shipment. This coal is moved via a giant conveyor belt over 100 feet high, directly into the plant where it is processed into a fine powder. This coal powder fuels 3 of the burner units, the 4th outfitted to burn natural gas. This power plant produces energy by using energy produced when burning coal to turn water into steam. This highly pressurized steam then travels through a series of pipes to a fan-like blade in a turbine. The turbine begins to turn, which causes giant wire coils inside the generator to turn, similar to a crank radio or flashlight. This creates an electromagnetic field, which forces electrons to move and creates the flow of electricity. This unit here, manufactured by General Electric, was put into service in 1963, with an operating output of 243 megawatts. Here, our videographer Nate records some video of Unit 2. Unit 2, pictured here, was also manufactured by General Electric and put into service in 1964. This unit has an output of 240 megawatts, which can power 250,000 homes. Unit 3, the largest of the 4 power-producing units, was put into service in the year 1969. This unit has the capability of producing a colossal 612 megawatts, more than the first 2 units combined. This turbine unit is nearly 3 times the size of its predecessors, taking up the majority of the floor space on the 2nd story of the plant. That brings us to the 4th and final unit, also dubbed the Bastard Sister, which was put into service in 1974. This unit burns natural gas and is the least desirable unit and is only used during peak demand. It is coupled to a General Electric turbine that can generate 435 megawatts. The energy created in this plant is not stored, but rather fed directly into the grid. Well, enough turbine talk. It's time to leave the power station building and make our way to the cooling towers at the adjacent side of the plant. With the amount of extreme heat produced by these 4 burning units, it is clear that a cooling system is necessary to keep things cool. For that reason, the plant was constructed on a natural peninsula, strategically located on the Mount Hope Bay, giving it access to millions of gallons of cool Atlantic sea water. This water is pumped through an array of pipes and filtered through screens that filter out any fish or aquatic organisms. This filtered ocean water is then pumped into the plant where it acts like a radiator. Once used, the warm water is then pumped out to the cooling towers using high-volume pumps. The pump station was built in conjunction with the cooling towers and is the home of hundreds of feet of conduit and walls of electrical components. Once we made it into the pump station, we were able to see the massive pipes with a diameter of 7.5 feet. This pipe system transports the water 85 feet up into the cooling towers. The cooling towers are surrounded by a 40-foot noise reduction wall that acts as a barrier to noise pollution. In the next clip, you will hear an actual sound made by the water cascading down the cooling towers. Next, we made our way up to the stairway to the first tower. This stairway is constructed of fiberglass to resist corrosion. Here is the sound of the towers at that height. The bridge from the stairway to the towers provides us with a magnificent view of Fall River and neighboring towns. At a height of 496 feet, these towers act like a large chimney, cooling the water as it cascades down. Upon entering, we see the drift eliminator system, which captures stray emissions. The next clip is the actual sound from within the tower. That sound you heard was the sound of water being dispersed across thousands of spray nozzles, which spray the hot water down the tower. Next, after leaving the tower, we made our way down the stairs and over to the discharge basin, where water is transported via 9-foot pipes. This cool water flows downward using gravity, as it was strategically built lower than the towers. This water encounters a series of dams in an effort to slow the water down prior to reaching the lower basin. 95% of this water is recirculated back into the cooling process. In this final stage, a partial amount of water will be discharged back into the bay, but at a much cooler temperature than prior to the cooling tower construction. Well, this is the end of the tour, and we couldn't close the tour without a group picture. Thank you.